Welcome to Coding with Tom. Today we will start with our new app in SwiftUI, Castles. We will be using this as a starting point for future exercises. Here what we do is we have a kingdom with different castles. We perform actions in our turn which can be attacking to gain loot or fortifying castles to repair them and increase their attack and defense power. In this session we will be creating the shop where we will be able to purchase items to enhance our castles. The challenge here is that ShopItem is a protocol that has multiple types conforming to it. Somehow we need to manage to have this array of polymorphic items conform to the Codable protocol. Let's do a quick walkthrough of the code. Here in our model we have our kingdom. A kingdom just has an amount of gold and an array of castles. For the castle we just have the ID, the name of the image, the name of the castle, the HP, the attack power, and the defense power. To ensure that we don't have negative HP, we have setter methods. We have an outcome that has three different types. Either we fortify, we attack, or we get plundered. Here we have the turns where we're just checking if the turn was on the player, and here is where the challenge comes from. So we have a protocol, which is item, and we have shop item. So we always will have shop item with the common attributes, and inside the shop item we will have a wrapped item which conforms to this protocol. Next we have our services. So nothing new with the services here really. We have 4 different services to manage the shop, the turns, the outcome, and the kingdom service. Notice how here we have commented out the code in retrieve and save data. That's because shop item cannot be codable yet. Each of them will be storing the information of the see fit and communicate the changes with publishers. Here we have the outcome. Here's where we quantify the result of an attack or a defense with different multipliers. If we want to change the interaction, we just have to modify this class. Our source of truth regarding the kingdom lies here in the kingdom service. Just like with the other services and how we have done before, we have a shared instance. We have publisher methods here, mutating functions, and we're storing everything using Codable. As usual, we have use cases that interact with all of our service. We already did all of the use cases necessary for this exercise to retrieve the publisher, spend shop items, purchase them, apply them to castles, attack with castles, and proceed to the next turn. Here we have the presenters that will be transforming our model entities to view models. Right now we have created the one that displays the currency in a formatted way, a castle, and the turns. For our two scenes, right now we have the dashboard. This is the view where we are seeing the castles, where we can add castles, where we see the next turns, and where we can perform the actions of attacking, fortifying, or moving on to the next turn. Here we have our SwiftUI view. Important here to mention SwiftUI previews don't currently support too well landscape orientation, so our previews have this portrait appearance for now. After the user performs an action, be it attacking, defending, or moving on to the next turn, an outcome will be notified, and that's when we display this outcome view, which is just a summary of the recently performed action. Okay, and that was the code. Now let's move on to our model and make shop item codable. Now you'll see that as soon as we make shop item codable, we'll get an error. This is because we need to implement manually the decodable and encodable protocol. Thanks to this, we have different structs that conform to item. I forgot to mention in the introduction, because we have polymorphism here, what we are using to deal with the different types is the visitor design pattern. We create a coding keys enum with a case for each of the variables we have. Then what we're going to do is in our init from decoder, we create a container from those coding keys. with that container, we decode each of the variables. For the value type, it's really easy since string, int, and all of those are decoded easy. For our item type enum, we need to make it conform to Codable, and then we get away with the decoding. And now the interesting part comes for the wrapped item. I forgot to mention that the type is a private enum that we're just using to encode and decode. Now here I want to be organized and use a method to decode because I cannot use methods until I initialize all of the variables. We're going to give the wrapped item a default value of attack item, and then we're really going to decode it in this function. Here is where the item type comes into play when decoding. Depending on this type, is that I decide which of the types I'm going to use to decode. So in this case, because it was a type attack item, I'm going to use the attack item struct as a reference when decoding the wrapped item key in our container. And we do the same for the other types. For encoding, we do something similar. We create a container using our coding keys. And again, for the value types, it's really easy. You just encode with the container the variable with one of the coding keys. Notice what happens when we try to encode wrapped item. It's telling us that the protocol doesn't conform to encodable, so we have to do it ourselves. So here what we're going to do is we're going to cast wrapped item to each of its conforming types. Because we are casting, the concrete type can be encoded. With these changes, now our project can build. Now let's move on to our scenes. For the sake of time and avoiding repetition, I'm going to skip several parts of this exercise. As you can see here in the view model, we have nothing new. We have a public variable, which are the items. This is all from the array of ShopItem view model, which our view is going to be displaying. Here we need a presenter that will transform our shop items into ShopItem view model. For that, we create a presenter. Now here in the presenter, what are we going to do given that we have a shop item? Remember that we have the shop item visitor protocol, and that's what we're going to implement here. Now, when we are visiting a castle item, what remodel should we create here? We're going to do again the same. Castle item has a visitor, so for that we're going to create another presenter that will visit the different types of castle items. We're going to need two more methods from our view model. One will tell us if the selected item is an item intended for a castle, that is, if the item is a castle item. And then we're going to have another one which applies a castle item to a castle that the user selected. This is our shop view. So what we have is a navigation view with a scroll view that scrolls horizontally. We have a lazy edge grid for each of the items, which we are all displaying in the shop item view. And that's what we're currently working on right now. What we're missing here is when the user taps, we're going to be displaying an action sheet on iPhone or a pop-over on iPad. SwiftUI already provides us with the ActionSheet modifier. This presents an action sheet in iPhone and presents a popover in iPad. Let's try with this. Here is our shop. Let's tap on an item. We got our action sheet with the names of the castles. Let's select Swift Stronghold. Notice that the quantity decreased there, and now we have 20 more of attack. Let's try running it on iPad. Now see that we do get the shop, but when we tap on an item, our popover is not getting anchored to the selected item. To be honest, I couldn't find a solution for this. I don't know if it's the lazy edge grid or the scroll view, but whenever trying to apply the action sheet modifier to an item inside of it, I could never get it to anchor to it. So what we're going to do is create a view outside of the scroll view and anchor the action sheet to it. Before we implement that fix for the action sheet, we had a bug. We created one actually. Having two sheet modifiers like this was not working. We were not displaying the outcome. So what we're going to do is we're going to use one sheet modifier in this view, and we're going to distinguish which view to present with this in a dashboard sheet. So in our state, we'll have the dashboard sheet, and we will just have one boolean for presenting or not the sheet. Okay, so we run into a little bump. What's happening is this implementation that I did with the dashboard sheet state, because I'm changing two states at the same time, the dashboard sheet and the boolean. The state was not getting passed down, so the boolean was being changed, but not our model. I found this thread where another user was having this issue. They were changing a boolean flag and changing the state, but the state of the variable was still nil. I didn't see a solution, nor did I find an answer, so we're gonna do a workaround for this. So what we're going to do is we're going to store this state change inside of the dashboard view model. I'm not very happy about it, but it's what we have right now. Now let's try this. We are now displaying the shop, and let's see for an outcome. And there we go. Now to our original issue where we cannot anchor the action sheet to the items. I'm gonna place this object on top of the scroll wheel, and let's add the action sheet modifier to this one so that it's always anchored to this object that we're only displaying when a castle is selected. Let's try running. Let's select an item, and here we see how it's anchored to that view. Now let's move the view to be displayed in the top left. And that was all for today. We managed to make shop item decodable by implementing manually the init from the coder and the encode. This will be our new app. We will be using this quite a lot. It proves to be quite a challenge this time with the action sheet, which wasn't intended, by the way. But yeah, we'll be using Castle for further exercises. We'll also use it to create widgets with SwiftUI and hopefully integrating it with a watchOS application. Hope you liked it. See you next time. Bye.